This material is taken from the Total Quality Management Chapter 10, contains QFD. Quality Function Deployment, QEFD, is a systematic planning tool introduced by Dr. Mizuno, Professor Emeritus of the Tokyo Institute of Technology. The first application of QFD was at Mitsubishi Heavy Industries, Limited, in the Kobe Shipyard, Japan, in 1972. After refinement and training, Toyota successfully implemented QFD in the production of minivans in 1979, reporting significant reductions in startup costs. QFD is a disciplined approach to product design, engineering, and production, focusing on translating customer expectations into engineering or technical characteristics. It can be applied to various industries, becoming a standard practice for leading organizations and their suppliers. Key aspects of QFD include 1. Customer focus. QFD centers around the voice of the customer, aiming to fulfill their expectations or requirements. It helps prevent conflicting characteristics or requirements early in the product development process. 2. Team-based approach. QFD is a team-based management tool involving members from marketing, design, quality, finance, and production. Teams can either work on designing a new product or improving an existing one. 3. Benefits of QFD. Reduces startup costs and product development time. Improves engineering knowledge, productivity, and quality. Identifies conflicting characteristics early, reducing midstream design changes. Enhances teamwork and communication across departments. Provides documentation and creates a historic reference for future technology. 4. Implementation steps. When an organization decides to implement QFD, the project manager and team members commit significant time. The scope of the project must be clearly defined, and effective communication is crucial. 2 types of teams, designing a new product or improving an existing one, require efficient use of time and inter-team communication. 5. Benefits of QFD. Improves customer satisfaction by meeting or exceeding expectations. Reduces implementation time and the need for engineering changes. Promotes teamwork and communication across departments. Provides documentation for future design or process improvements. Focuses on customer requirements, reducing redesign and modification time. 6. Customer information collection. QFD starts with market research to determine customer expectations. Various sources, including focus groups, surveys, complaints, and industry standards, are used to gather customer information. 7. Affinity diagram. This tool organizes a large amount of data by grouping related information, making it useful for sorting and organizing thoughts during the QFD process. 8. House of quality. The primary QFD chart, representing a framework of a house, includes customer requirements, exterior walls, technical descriptors, ceiling, second floor, relationships between requirements and descriptors, interior walls, interrelationships between descriptors, roof, and prioritized technical descriptors, foundation. The House of Quality, HOQ, is a tool used in quality function deployment, QFD, to translate customer requirements, what's, into engineering characteristics or technical descriptors, how's. The process involves several steps, and the matrix helps organize and prioritize information. Let's summarize the key steps in building a house of quality. Step 1. Identify customer requirements and technical descriptors. Identify customer requirements, what's, and technical descriptors, how's. Establish relationships between customer requirements and technical descriptors in the relationship matrix. Step 2. Add interrelationship matrix. Include an interrelationship matrix to analyze the relationships between technical descriptors. Step 3. Add competitive assessment. Create competitive assessments for both customer and technical aspects. Compare the organization's products with competitors' products based on customer requirements and technical descriptors. Step 4. Add prioritized customer requirements. Prioritize customer requirements by assessing importance, determining target values, calculating scale-up factors, assigning sales points, and calculating absolute weights. Step 5. Add prioritized technical descriptors. Prioritize technical descriptors by assessing degree of difficulty, determining target values, and calculating absolute and relative weights. Step 6. Develop prioritized customer requirements. Prioritize customer requirements based on importance, target value, scale-up factor, and sales point. Calculate absolute weight for each customer requirement. Step 7. Develop prioritized technical descriptors. Prioritize technical descriptors based on degree of difficulty, target value, absolute weight, and relative weight. These prioritized matrices provide a structured framework for decision-making in product development, helping teams focus on areas that require improvement and guiding the allocation of resources. The weights and rankings obtained from these matrices can be used to create a Pareto diagram, enabling a visual representation of the most critical factors influencing the product's success in meeting customer requirements. Overall structure. The HOQ is structured like a house, with what's, customer requirements, forming the foundation, how's, technical descriptors, forming the second floor, and interrelationships forming the roof. The relationship matrix and interrelationship matrix help visualize the connections between what's and how's. Purpose. The House of Quality aids in prioritizing design efforts, resolving conflicting requirements, and ensuring that customer needs are met. It provides a visual representation that facilitates communication among cross-functional teams. Example. Problem. Using the mountain bike handlebar stem example, the matrices help in understanding relationships and making informed decisions in the design process. In summary, the House of Quality is a systematic approach to product development that ensures alignment with customer requirements and helps manage trade-offs in the design process. 1. Refinement of QFD. Chart. Create a new chart where the technical descriptors of the previous chart become the customer requirements of the new chart. Refine technical descriptors until an actionable level of detail is achieved. Carry along how much values, prioritize technical descriptors, to facilitate communication. 2. Complete QFD process. Flow. Illustrate the flow of the complete QFD process from product planning to production planning in a flow diagram. Examples of other QFD planning charts that can be used to improve quality and customer satisfaction include demanded quality chart, quality control process chart, reliability deployment chart, and technology deployment chart. These charts are selected based on the type of product and the scope of the project. Finally, the QFD approach has been successfully applied in various industries, with examples such as Toyota's Rust QFD study in the automotive sector and its application in higher education institutions like Rainstar University and Tennessee Technological University's College of Business Administration. The examples highlight how QFD can be used to design products and services that meet customer needs and expectation.